This is for the place value and rounding review sheet number 1. Okay, so problem number 1 here. Using base 10 blocks, write the number in standard form. Now remember, standard form, another word for standard, is regular form. So when we talk regular form, that's just using numbers. So I see here, this is one of those large cubes, those 1,000 blocks, and I see one of them. So I'm going to put a 1 in the thousands place, and then my comma. I note here that there's actually no hundreds. I don't see any at all. So to show no hundreds, I would put a 0. Then I see one of these longs. That's a 10. And I see there's only one 10, so I will put a 1 in the tens place. Then I see lastly there's 3 little cubes. And those 3 little cubes show that there should be a 3 in the ones place. So my final answer is 1013. Alright, question number 2. Write this number in standard form. Once again, standard form means regular numbers. This time I do see that it's in word form, so I do need to be able to read this and put it into those number forms that we usually see. So one thing I want to do is kind of break the problem into 2 parts. I see that comma there, and I split it there to show the thousands place differing from the units place. So I can see here 12,000. So I can make a 12. I've done that. And then I'll put the comma there, the same one that actually matches what it says in the original place here. There's that comma. And then I see here, the last part of it is 405. 400s, and I don't see anything about tens in there, so I'm going to put a 0 to show that there's no tens. And then, of course, 5. So if I double check, it does say 12,405. 405. So that should be my final answer. Okay, so my next problem tells me to write this number here in expanded form. An expanded form means you expand or stretch the number out into its various place values. So I see this number 17,301. So I'm looking here, and I'm going to start with the highest place value first. And I'm going to say this is a 1 in the 10,000s place, and I'm going to change all the rest of the numbers to zeros. Remember, we call this the pizza format because it looks like there's a lot of pepperonis, and by the time we get done, it does look like a pizza. I see my next place is a 7 in the thousands place, so I'm going to write 7,000. Then my next place that I see is a 3 in the hundreds place, so I'm going to write 300. Then I see a 0 in the tens place, and this is kind of a personal choice thing. If you like to show that there's no tens, you can actually put a 00 there. Or if you feel like that's not necessary because zeros are zeros, you actually don't have to put those even at all. And you can just simply say there's a 1 in the ones place and just simply put it there. That's entirely up to you. The last thing to do is put a plus sign and then show that this does, if you add all those pieces up, you do get 17,301 back. Now, if you have a long line like this in the answer, this pizza format is not going to fit very nicely on there. You can switch it to the breadstick format and just simply write them in order on the line. 10,000 plus 7,000 plus 300 plus 1, and all of those together equal 17,301. Okay, problem number 4. Write this number in standard form. So this is the opposite of what I just did. They just gave me the expanded form. Now I need to go into standard form. Honestly, one of the things I like to do with this is actually set it up like an addition problem, because it's a very simple addition problem with all of the zeros. The only thing is, just make sure you line up all of the edges here. So now that I'm going to write 800, I'm going to make sure that my zeros all line up along this same line. And same with the 50, line it up right along that line, and the 6. And now I have a quite simple addition problem. 0 plus 0 plus 0 plus 6 equals 6. 0 plus 0 plus 5 equals 5. 0 plus 8 equals 8. And then my comma. And then I really don't have anything left to add. I just have that 30,000 hanging out. So I'm going to drop it down here. So going into standard form, the number looks like 30,856. Okay, on to question number 5. Compare the following numbers. Write a greater than, less than, or equal to in the blank. So I'm looking at these numbers, and I think I'm going to write them a little larger here for us. 17,649 and 17,634. Now the first thing that I want to do is I want to count the digits in each of these just to make sure that I have the same number of digits. If I have more or less, that automatically makes that number more or less. I see in this one I have 1, 2, 3, 4, 5 digits. And in this one I have 1, 2, 3, 4, 5 digits. I can't tell which one is greater because they both have 5 digits. So now what I need to do is I need to compare the places. And I always start with the highest place value. So if I take a look in the 10,000s place, I see that there is a 1 in each of those. I can't tell which one's greater at this point because they both match. Now I'm going to move to the thousands place, the next highest place value. And I see that they're both 7s. I can't, once again, tell because 7 is equal to 7. So I'm going to go down to the next place value, which is a 6 in the hundreds place. And both of them have a 6. No comparison here yet. I'm going to go to the tens place. Aha! This is where I finally find a difference. Over here on the left, I see that this one has a 4 in the tens place, and on the right, this one has a 3 in the tens place. And I can see that 4 is larger than 3, or, because it's in the tens place, 40 is greater than 30. So I now know that this number over here is greater than this number over here. So all I have to do is put in my greater than symbol. So 17,649 is greater than 17,634. Okay, on to question 6. Write the following numbers in order from greatest to least. One of the easiest ways to have troubles on this one is to not pay attention to reading the problem. This one does say greatest to least. What I suggest you doing is making 4 lines since there's 4 different numbers. And I suggest you label these. This case, the problem says greatest comes first. Simply put a little G under there just to remind yourself that the greatest goes there. And the least should come last. So you want to put a little L under there. And in this case, we have 2 that are in the middle. So now I'm going to go through and see if I can find out which one is larger. So I'm looking, each of them have 4 digits. Okay, I can't tell anything from there. So now I'm going to take a look at the thousands place in each of these and see if I can find that, because the thousands place is the highest. I see this one here has 7,000. This one here has a 3,000. That one does seem kind of small. And a 7,000 on this one. And a 9,000 on this one. By simply looking at the thousands place, I've actually found the greatest and the least right at the same time. I see that 3,000 is my smallest one, because 3 is smaller than 7 or a 9. And I also found that 9 is my largest in the thousands place. So I can actually put those in right now. So I'm going to go ahead and put in 9,000, 450 as my greatest because of that 9 in the thousands place. And I'm going to put in my 3,281 as my least. So I've done this one and I've done this one. That leaves my two middle numbers down here to figure out. And I have a 7,000 and a 7,000. Alright, I'm going to take a look and see if I can go into my hundreds place. See, my hundreds place in this one is a 600, and in this one's a 600. Once again, I can't tell which one is larger. So I'm going to go to my tens place. I see a 3 in the tens place here, and a 2 in the tens place here. Now I can tell. A 20, where a 2 is in the tens place, is less than where there's a 3 in the tens place of 30. That means this number here is a larger number than this number here because of what's in that tens place. So now I can complete my problem and say that 7,632 is the second biggest. And then I can put my 7,629 as my next smallest moving down the line. Make sure again you count the digits first and then start at the highest place value to compare. Okay, number 7. Which digit in the number 65,201 is located in thousands place? Alright, I'm going to go ahead and actually write this out using our place value blank formats. I know that my place down here is the ones place. Then my next place is the tens place. Then I have my hundreds place. And then over here, my next place is actually the thousands place, the first one right after the comma. And then I have my 10,000s place. Okay, so if my question says which is in the thousands place, I'm looking for the one that's right here, the one that's immediately before the comma. So if I look at this number here, I see that it's a 5. I'm going to double check in my question. It says which digit in the number 65,201 is located in the thousands place. If I'm talking a digit, it's asking me for just a single number. And in this case, the single number is just simply 5. Okay? Okay. Write the following number below. Okay, I'm kind of just glancing over the problem. I see ones, thousands, tens, 10,000s, hundreds, and I see those blank lines again. I'm going to go through real quick and label those for myself so I remember which one's which. It'll make the problem simpler. So I know starting here, this is the ones place. This is the tens place. This is the hundreds place. This is the thousands place. And then this is the 10,000s place. So now all I have to do is follow the directions. I need to put a 5 in the ones place. There's the 5, there's the ones place. I need to put an 8 in the thousands place. Here's the thousands place here, putting an 8. Done. Now I see that this is the 6 in the tens place, so I'm going to put a 6 in this tens place. Then I see that the 10,000s place, I need to put a 3, so I'm going to put a 3. And lastly, it says a 0 in that hundreds place. Good, my last place is the hundreds place, and I'll put a 0. So my final answer is 38,065.